Hi, Dr. Aisha. We are going to present the topic of broadcast in-situ concrete piles.
Hi, I'm Eng Kai Chun. You can call me Casey.
Hi, I'm Sahil Ganesh.
Hi, I'm Wani.
Hi, I'm Karen.
Hi, I'm Daphne.
In general, board piles offer the most economical foundation as they can be constructed in a wide choice of diameter, typically ranging from 300 to 1,800 mm and to depth of up to 70 m at racks of up to ratio 1 to 4. Board piles can be classified into two main groups according to their load-bearing behavior: friction piles, which transfer load mainly by frictional resistance along the shaft, and end-bearing piles in which load is primarily transferred to the surrounding soil of through the pile base.
Hi, Casey here. I will briefly name a project that used broadcast in-situ concrete pile in Malaysia. The following photos show the electrified double tracking project which located between Ipoh and Padang Besar, Malaysia. The project used broadcast in-situ concrete pile mostly for a retaining wall, and it took almost half a year to complete it. The electrified double tracking project are done by Econ Pile Holdings Berhad. Econ Pile Holdings Berhad has one of the largest and most advanced arrays of piling equipment in Malaysia. It offers various of equipment which are manufactured by German-based Bauer groups. Last but not least, Econ Pile Holdings Berhad serves the property development and infrastructure sectors, mostly in Malaysia. The photo is one of the examples of piling work which are done by Econ Pile Holdings Berhad. The piling works are located at Sepang, Gold Coast, Malaysia.
I'm Karen. I would like to talk about the function of broadcast in-situ concrete pile. First, a board pile is a non-displacement form of foundation that is cast in-situ and provide economical load-bearing and walling solutions suited to a wide range of ground conditions and applications. Second, usually board piles are used for support those tall buildings or massive industrial complex which producing heavy vertical loads and require foundation that can build a load of thousands of tons, most probably in unstable or difficult soil conditions. Third, board pile is used in construction as a foundation, especially for bridge work and tall buildings as well. Board piling work has to be done by specially board piling contractor. Normal piling contractor cannot execute this type of work without experience and knowledge about board piles.
I'm Sahil, and I'll be talking about the advantages and disadvantages of the broadcast in-situ concrete pile. Concerning the advantages, the length of the pile can be varied to suit the varying ground conditions. Piles can be installed to very long length. The soil removed in boring can be inspected, and if ever necessary, it can be sampled or made in situ. Also, it can be installed in large diameters. Damage due to driving and handling, which is common in precast piles, is eliminated. It can be installed without much noise and vibration, so adjacent piles and structures won't be disturbed. It can be used in places where vibrations and noises need to be avoided. It can be installed in places of low headroom. Finally, there's no risk of ground heaves. Now, concerning the disadvantages. The installation of piles requires careful and quality control of all materials used in construction. Method is cumbersome. It needs storage space for all materials. It cannot be readily extended above ground level, especially in river and marine structures. It is susceptible to wasting or necking in squeezing ground. The increased bearing capacity obtained by a driven pile due to the compaction in granular soil is not produced by cast in-situ pile. Also, the concrete cannot be subsequently inspected. And finally, the boring method may loosen sand or gravelly soils.
I am Wan Yi. I would like to present the construction process of broadcast in-situ concrete pile. There are two methods used in construction of board pile, which is dry method and wet method. First, dry method. It is applicable when the soil and rock are above the water table, and the soil and rock will not cave or slump when the hole is drilled to its full depth. And the soil that meets this requirement is a homogeneous, stiff clay. The concrete pouring technique used in this dry method is funnel, whereas for the wet method, it is applicable when the water table is high and the sides and bottom of the soil in the board hole is unstable and required to be stabilized by bentonite or polymer slurry. It is applicable in all types of soil. Besides that, the concrete pouring technique used in this wet method is trimmy pipe. Before excavation of each board pile, stake out and referencing of proposed pile location by using theodolite. Pre-boring of required depth is to be done using a drilling tool such as drilling bucket or auger. In this video, they are using drilling bucket as it is mainly used for drilling water-bearing sandy soil, sludge, clay, sand gravel and weathered soft formation. Whereas augers are suitable for drilling in weak fracture rock and very dense sand and gravel. At the same time, pump the bentonite slurry, a water-based drilling fluid, or polymer-based slurry into the board hole when soil is removed from the hole. Bentonite slurry is used to support the sides of board hole by exerting hydrostatic pressure on its wall to prevent the collapse of soil. Insert the temporary or permanent casing to the board hole by vibrating motion exerted by the vibro hammer. Drill a borehole using augering method on drilling bucket. If you are using augering method, the auger is lowered down by a telescopic boom to excavate soil and retrieve the auger to the top after excavation. Move the auger with soil in it away from the excavated hole by swinging the machine. The augering process is repeated until the required depth is reached or hard layer of rock is reached. In this case, they are using drilling bucket to drill the board hole with the process similar to the auger. Move the bucket with soil in it away from the excavated hole by swinging the machine. The pressure in the board hole will force excess bentonite slurry to go upward. The overflow slurry is passed through channels and is collected in sediment tanks where the sediment settle and bentonite can be reused. Prefabricated reinforcement cage is prepared based on the drawings and approved depth or boring is in progress. The link shall be prepared first and subsequently tie the required reinforcement spaced equally onto the link. Once the reinforcement cage are ready, they can be installed into the hole until required depth is reached. The cage shall be lowered down into the hole segment by segment by using a suitable crane. The top of the cage will be welded with a suitable hook for lifting of the cage. Set up a working platform to the top of the temporary casing. If the ground is soft, using steel plates. The trimmy pipe section will be inserted and be jointed until it reaches the bottom of the board hole. Some test is used to test for the workability of fresh concrete. Concrete is poured into the trimmy pipes through hopper to form the board pile. Concreting will be carried out in one continuous operation to a stop-off level. The trimmy pipe can be removed one by one as the concreting goes on. Once the trimmy pipe is removed, temporary steel casing is extracted simultaneously by vibro hammer before the concrete hardens. If a length of permanent casing is required and already installed to depth, leave the casing intact after concreting. Broadcast in-situ concrete pile form when concrete is hardened.
I am Daphne. I would like to talk about problem occur during both case in-situ concrete pile construction process. One of the problems of both case in-situ pile is the design of pile reinforcement. The major problem in design of pile reinforcement is spacing. A minimum spacing of 100 mm is required, otherwise the concrete will not flow outside the cage, and proper cover could not be provided. A few diameter bar are preferable in place of small diameter bar. This problem is visible during concreting when cage draft downward into the borehole. Another problem can occur during concreting the pile. Concreting of case in-situ pile is a special operation and it requires considerable skill and correct concrete mix design. Mixers are designed having sufficient workability so that they are self-compacting and should not failing. Some tests in field is adequate to assist the former properties. To achieve above use are round aggregates, high sand content, and pasteurizer. Super pasteurizers should not use because this reduces the setting time of concreting. The concrete is placed in borehole using trimmy pile to avoid segregations, impining of concrete on the side of the borehole. The trimmy pile should be at least 1.5 meter and bended in concrete during concreting process. Otherwise, bentonite mix in concrete and result in the weakness of pile shaft. Overflow of concrete should be sufficient. Otherwise, bentonite remain in concrete which weakens the pile shaft, as shown as this picture. Another problem occurs during construction is poor cleaning of the cut material. When it is large diameter and deeper pile are adopted, the area has very soft clay up to 22 meter. The capacity of the cleaning pump used and the duration of cleaning should be adequate to achieve proper flushing out of all cut material. Design of bore pile in soft ground also presents difficulty in the ability of the excavation hole to remain open prior to formation of the pile. For very large bore pile, base failures of the excavated base may be a problem in soft ground, preventing the pile from achieving the desired top, level, and length. Basa heavy failure. Sharp failure is occur in very soft clay. This failure mechanism is analogous to a bearing capacity failure, only in reverses being the stress in the ground are relieved instead of increased. Hydraulic failure. For site with high groundwater level in sandy subsoil, a simple check against hydraulic failure can also be carried out to assist the constructability of the piles in such conditions. This problem can also be easily solved by using suitable drilling flues to balance the hydrostatic pressure. Soft ground having undressed strength less than 15 kN per meter square, causing the squeezing of the pile section near the head, because lateral pressure of soils is more than the lateral pressure of concrete. In conclusions, both case In-Situ pile installation is require full-time supervision of pile construction should be carried out by an experienced engineer, which gives us the designed pile capacity.
That's all for our presentation. Thank you.